Of the lesson, the learner is able to solve problems involving rate of interest and time in compound interest. And our lesson outline: number 1, interest and time in compound interest. Number 2, equivalent interest rate. So finding the number of periods n for compounded interest using the formula for maturity value f, present value p, and interest rate g. So f is equal to 1 plus g is raised to the power of n, then logarithm of f is equal to logarithm 1 plus g raised to the power of n is equal to n logarithm of 1 plus g. Thus, n is equal to logarithm f over m logarithm of 1 plus g. So, first example. How long will it take 3,000 pesos to accumulate to 3,500 in a bank savings account at 0.25% compounded monthly? So the given is our present value is 3,000 and our maturity value is 3,500 and our I raised to the power of 12 is equal to 0.25%. And we need to convert this into decimal, that's why 0.0025. And RM is 12 and RG is equal to I raised to the power of 12 over M is equal to 0.0025 over 12. So our solution, substituting the given values in the maturity value formula, F is equal to P times 1 plus G raised to the power of n. And the result is 3,500 is equal to 3,000 times 1 plus 0.0025 over 12 raised to the power of n. And then divide both sides by 3,000, so 3,500 over 3,000 is equal to 1 plus 0.0025 over 12 raised to the power of n. To solve for n, take the logarithm of both sides. Log plus 3,500 over 3,000 is equal to logarithm of 1 plus 0.0025 over 12 raised to the power of n. So logarithm of 3,500 over 3,000 is equal to n logarithm 1 plus 0.0025 over 12. So n is equal to logarithm of 3,500 over 3,000 over logarithm of 1 plus 0.0025 over 12 is equal to 740.00. Thus, payments must be made for 740 months, or T is equal to N over M. The 740 over 12 is equal to 61.67 years. So the next example is, how long will it take 1,000 pesos to earn 300 if the interest is 12% compounded semi-annually. So given f is equal to 1,300, I raised to the power of 2 is equal to 0.12, and m is equal to 2, and g is equal to I raised to the power of 2 is over m is equal to 0.12 over 2 is equal to 0.06. So we will find n and t. So our solution is f is equal to p times 1 plus g raised to the power of n. So 1,300 is equal to 1,000 times 1 plus 0.06 raised to the power of n. So 1.3 is equal to 1.06 raised to the power of n. So logarithm of 1.3 is equal to logarithm of 1.06 raised to the power of n. So logarithm of 1.3 is equal to n logarithm of 1.06. So n is equal to logarithm of 1.3 over logarithm of 1.06 equal to 4.503 periods, because interest is earned only at the end of the period. Then 6 months periods are needed so that the interest can reach 300 pesos. Thus, n is equal to 5 and t is equal to n over m is equal to 5 over 2 is equal to 2.5 years. It will take 2.5 years for 1,000 pesos to earn 300 pesos. Finding the interest rate G per conversion period using the formula maturity value F, present value P, and interest rate G. So the formula is F is equal to 1 plus G raised to the power of n. Then n divided by f is equal to 1 plus g, thus n is equal to n raised to the power of n divided by f is equal to 1. So using g is equal to 1 raised to the power of m over m, then I raised to the power of m is equal to mg. So we are going to proceed example 3. At what nominal rate compounded semi-annually will 10,000 pesos accumulate to 15,000 pesos in 10 years? So given, so the F is 15,000 and the P is 10,000 and the T is 10 and the M is 2 and the N is equal to M, T and equal to 2 times 10 is equal to 20. So we will find I raised to the power of 2. So the solution is F is equal to P times 1 plus G is equal to raised to the power of n. 15,000 is equal to 10,000 times 1 plus g raised to the power of 20. So 15,000 over 10,000 is equal to 1 plus g raised to the power of 20. So 1.5 equals to 1 plus g raised to the power of 20, and 1.5 raised to the power of 2 over 20 is equal to 1 plus g, and 1.5 raised to the power of 1 over 20 is minus 1 is equal to g. So the g is 0.0205. So the interest rate per conversion period is 2.50%. The nominal rate or annual rate of interest can be compounded by g is equal to I raised to the power of m over m is 0.0205 is equal to I raised to the power of 2 over 2, and I raised to the power of 2 is equal to 0.0205 times 2, and I raised to the power of 2 is equal to 0.0410 or 4.10%. Hence, the nominal rate is 4.10%. So our example 4, at what interest rate compounded quarterly will money double itself in 10 years? So given as is f is equal to 2p plus and t is equal to 10 years, and m is equal to f equal to 4, and n is equal to mt equal to 4 times 10 is equal to 40. So we will find I raised to the power of 4. So the solution is f is equal to p times 1 plus g raised to the power of n, and 2p is equal to p times 1 plus g raised to the power of n. So 2 is equal to 1 plus I raised to the power of 40. So 2 raised to the power of 1 over 40 is equal to 1 plus g, and 2 raised to the power of 1 over 40 is minus 1 is equal to g. So g equals 0.0174 or 1.75%. The interest rate in each conversion period is 1.75%. So the nominal rate can be computed by g is equal to I raised to the power of 4 over m, and 0.0175 equals I raised to the power of 4 over 4, and I raised to the power of 4 is equal to 0.0175 times 4. So I raised to the power of 4 is equal to 0.070 or 7%. Therefore, the nominal rate that will double an amount of money compounded quarterly in 10 years is 0.0%. So our definition of terms equivalent rates is two annual rates with different conversion periods that the same maturity value for the same time and term. And our nominal rate is annual interest rate, or may be compounded more than once a year. And our effective rate is rate when compounded annually will give the same compound each year with the nominal rate denoted by I raised to the power of 1. That's all. Thank you.